So imagine we're writing a SQLite-powered blog, and we've got this posts table that looks like this, but we've got a problem right now, which is the fact that we're querying this table by the slug like this, but the query is slow because there's no index on this slug column. Okay, so what should we do to fix this? Well, obviously we could add an index to the slug column like this, but let me ask you, is this the best optimization we can make? In other words, does adding this index cause the query to run as fast as possible? Well, this might surprise you, but no. This index will help immensely, but we can actually do better. In fact, there's something we can do which can make this query run about twice as fast, and it involves a special kind of an index. But before I talk about this special index, I want to make sure you understand how a normal index works. So there's a hidden column in this post table named ROWID, and you can actually see this ROWID column if you explicitly add the ROWID to the select clause. Now, I didn't add this ROWID to the table, it's automatically added by default to all normal tables. Okay, so what's the point of this ROWID? I mean, what's it used for? Well, you can think of the underlying storage of our blog post data to logically look something like this. Basically, the post data is stored in order by the ROWID, and if you know the ROWID you're looking for, you could query for a post by the ROWID, and the query planner will perform an efficient binary search to quickly find the row you're wanting. Now, would you ever run a query like this? Well, I would bet almost nobody runs queries with ROWIDs, mostly because they aren't really meant to be used directly like this, they're meant to be used indirectly. Let me explain how ROWIDs are normally used by looking at the index created with this statement here. So when this index is created, logically you can think about it being stored in the following way. Basically, the slug values are sorted in alphabetical order like this, and then each slug has its corresponding ROWID next to it. So if you were querying for this slug, the query engine would perform an efficient binary search to find the slug in the index, then the query engine would use the corresponding ROWID to perform an additional binary search against the table to locate the underlying row, at which point the row data is returned as a result. So as you can see, this ROWID is how you go from normal indexes to the row or rows in the underlying table. Now notice, we didn't use the ROWID directly, we used it indirectly. Okay, so in summary, to satisfy this query, two binary searches happen. First, a binary search of the index, and then a binary search for the ROWID in the table. So this is how a normal index is used, to query a value, but this isn't the most efficient way of finding a post by its slug. So do you have any thoughts on how we can make this query more efficient? Well, what if we got rid of the ROWID and instead we ordered the table data by the slug? Then we wouldn't need to have this separate index. Instead, we could just do one binary search against the table instead of two, which is about twice as fast, and also since we're not using a separate index, we save on disk space as well. There's a name for this kind of an index. It's called a clustered index, and obviously you can only have one per table. Okay, so how do you set this up in SQLite? Well, here's the original create table statement, and to add the clustered index, we need to do two things. First, we need to make the slug the primary key, and secondly, we need to add without ROWID onto the end of the statement. Now, by doing this, we've eliminated the separate index, and now the table data is ordered by the slug, so when we run a query like this, the query can be satisfied by a single binary search of the clustered index. Okay, it's important to note that we aren't adding any new capabilities when we use a clustered index, we're simply adding an optimization. Alright, so when should you use the without ROWID optimization? Well, it's usually helpful for tables that have non-integer primary keys or composite keys that don't store large strings or blobs. Now, the general strategy on using clustered indexes in SQLite is to not worry about it until you're near the end of product development. Then you can go back and run tests to see if adding clustered indexes to tables with non-integer primary keys helps or hurts performance. Hey, here at Mycelial, we're big fans of SQLite, and we're building tools around SQLite that will allow you to synchronize a SQLite database to multiple computers without conflict. If you are interested in SQLite and what we're doing with it, please subscribe to our channel and consider joining our newsletter to learn more.